Dr. Marissa May. In this video, I'm going to be talking about the methods of subtraction. Now, if you have been like, oh, I know how to subtract, I just stack the numbers and all this stuff, this video actually might open your eyes because it's going to show you methods that teachers use with students of all ages to help them understand subtraction and gives them different options to show students, different methods to show students, so that maybe if they struggle with the standard algorithm, maybe they don't borrow so well, then they have another way to uh, still find the answer to a subtraction problem. So I'm hoping that this kind of gives you an idea of different ways that we can actually understand the subtraction. So let's take a look. Before we actually jump into the methods, I get a lot of questions about these old timey words, truthfully. Minuend, subtractand. Those aren't words we use a whole lot, but every once in a while we see them. And so I thought this diagram, this picture actually gave us a really good idea of what those words mean. I feel like difference is the word that we use so much. It's the answer to a subtraction problem. But here are some terminology I'm just throwing in for like, those just look like some old timey words. But there you go, food for thought. Let's start first with the number line approach. This is an approach that we see students very early on use in their subtraction and addition. By the way, if you haven't seen my addition methods video, I'll be sure to link it in the cards above. Let's take a look at problem number one. A building is 75 feet tall. A nearby tree is 25 feet tall. How much taller? That's phrasing we like to use to indicate subtraction. Is the building. So we're actually writing the problem 75 minus 25. Now, if you know the standard algorithm, I encourage you not to use it on this problem, but instead embrace the method of using a number line. So what we teach students is to first write down the starting point. That's the 75 on the number line. And then you're going to count back 25. But of course, we don't want students to have to 1, 2, 3, 4 if they don't have to. Instead, we teach them to skip count. Maybe they skip count by fives. This is 5 and 10 and 15 and 20 and 25. And wherever we land is our answer. So we landed at 50. This is one way we teach students to do that. And notice they don't have to know anything about stacking the numbers or any of that kind of stuff. Let's look at number two. This time we are given the number line and we want to write the subtraction problem that is shown. So think about, where's your starting point? I see the starting point at 51. How many times did you count backwards? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And where did you land? That's 37. So sometimes we display the subtraction problem with the number line and we have to read the subtraction problem from it. Sometimes we use the number line to actually do the subtraction. So let's take a look at another method. You may be familiar with the base 10 blocks. These are manipulatives that are used by teachers in classrooms in order to help students like touch and feel the actual numbers. So in this one, we want to write the subtraction blocks. We want to write the subtraction equation. So let's write how many blocks there are without any of the x's, okay? So I notice these are 10 rods, we call them. So I have 1, 2, 3, 4, 5, 6. Now, I may have said that wrong earlier. I want to write the number of blocks, and I don't want to think about anything that might have an X or not. Like, that doesn't matter, okay? So I have 6 10 rods. So 6 10 rods give me 60, okay? Then I have 1, 2, 3, 4, 5, 6, 7, 8 unit blocks, and 60 plus 8 would give me 68. Okay, now I want you to count the ones that have the X's on them. So you have 1 10 block, 2 10 blocks, and you have 1 unit cube, 2 unit cubes, 3 unit cubes, 4 unit cubes that have the X's on them. So I have 68 minus 24 because I put the ones with the X's on them as my subtractant. Use that old timey word. And then my answer are the blocks that don't have any X's on them. So that's 1, 2, 3, 4 10 blocks, and 1, 2, 3, 4 unit cubes. So I hope this helps how you can read the subtraction problem from the 10 blocks. Let's take a look at another method. All right. So the expanded form method. Friends, I have to be honest with you. This was not a method I was familiar with when I went to school. In fact, this wasn't even a method I learned when I was going to college to become a teacher. I had to learn this method when I homeschooled my third grader. Yeah, he really struggled with borrowing. He really struggled with that. And so we had to find other methods that would help him to do the subtraction while still practicing with the borrowing. So let me explain how this method works. You start with the expanded form of a number. We'll do 867 first. Now, expanded form means that we take each place value. So the 8 here is in the hundreds place. That represents 800. The 6 here is in the tens place. That represents 60. And then 7 is in the ones place. It represents 7. We'll do the same thing with 234. So 2 is in the hundreds place. It represents 200s. 3 is in the tens place. It represents 3 tens or 30. And 4 is in the ones place, and that represents 4. So now you subtract the values. All right, let's start with the ones place now. 7 ones minus 4 ones is 3 ones. 60 minus 30 is 30. And 800 minus 200 is 600. Now write your number across. So 633. Again, notice the student doesn't have to borrow in this case. Now, borrowing can happen in the expanded form. Borrowing can be done in the expanded form. However, I like this method because it shows the student the true value of that digit. Instead of seeing a 6 in the tens place, they actually understand that means 60. And so the borrowing is a little bit easier with this expanded form. All right, the final method I'm going to talk about is the standard algorithm. I referenced it earlier, but really I want to go over it only because a lot of people are taught this method and only this method. And I just want to kind of review it so you know what I'm talking about, especially when I referenced it in the other strategies. So notice that the numbers are stacked according to place value, making sure that we line up each of the place values. And then, of course, we do the subtraction. 9 minus 9 is 0. 5 minus 7, we can't do that. So we have to borrow from the 4, making that a 3 and making that 15. So 15 minus 7 gives me 8. And then 3 minus 3 is 0. So I get 80 as my final answer. Again, that's called the standard algorithm because it was the standard method to be taught in previous times. But I hope with this video, we've shown that there are other methods that you can use with students to help them understand subtraction. Bye for now.